The scene opens in a sterile, brightly lit architectural conference in Frankfurt, Germany. The air is thick with the scent of ambition and expensive cologne. European engineers, renowned for their steel, concrete, and industrial precision, are gathered to review global innovations. A young Filipino structural engineer, Miguel Alcantara, stands nervously beside a presentation screen showing a high-resolution image of a stunning, complex bridge structure, built entirely of bamboo. The project is revolutionary. Designed to withstand Category 5 typhoons and significant seismic activity using only locally sourced materials. Miguel begins his presentation, speaking of tensile strength, engineered joints, and the revolutionary laminating processes developed in his small Manila-based lab. He talks about sustainability, speed of construction, and cost efficiency. He talks about Diskarte, the ingenious resourcefulness necessary to build world-class infrastructure without a multi-million-dollar steel budget. The reaction from the European audience is not appreciation. It is barely concealed scorn. A senior German engineer, Dr. Klaus Richter, raises a hand and speaks, his voice booming with dismissive authority. Mr. Alcantara, thank you for your interesting model. But we build infrastructure meant to last centuries, not temporary garden sheds. Bamboo? We use steel. We use concrete. We use science. This is charming, perhaps. A craft project. But to suggest this is a viable engineering solution for cities. I'm sorry. We simply cannot take this seriously. Laughter ripples across the room. They laughed at the Filipino innovation, confident in their material superiority. Miguel felt the sting of cultural arrogance, but he remained calm. He knew he had data, and his data was about to silence them all. He pulls up the next slide, the results of the stress tests. Miguel took a deep breath, the laughter still echoing in the room. He didn't defend his culture or his material. He defended his mathematics. Dr. Richter, I understand your skepticism, but the material is irrelevant if the science is sound. We were tasked with creating an emergency shelter system capable of surviving a 300 km/h wind load and a 7.0 magnitude earthquake. We did it using a bamboo-based laminated composite, optimized by our proprietary joint system. He revealed the final slides. The data showed that the optimized bamboo composite had a tensile strength-to-weight ratio superior to structural steel, and its inherent flexibility allowed it to absorb seismic energy far better than rigid concrete. The European engineers fell silent, leaning forward, faces a mix of confusion and disbelief. Miguel continued, revealing the true shock: the failure rates. In laboratory simulations, the bamboo structure had a catastrophic failure rate 35% lower than the equivalent conventional concrete structure in combined wind and seismic tests. The bamboo didn't snap, it swayed, dispersed energy, and returned to form. The engineers realized the Filipino innovation wasn't about a cheap substitute. It was about a superior structural philosophy, flexibility over rigidity, sustainability over permanence. This moment of quiet, dignified defense of Filipino intellect is why this story needs to be told. If you're a true, full-blooded Filipino who carries the spirit of Puso in your chest, show your support and subscribe to this channel right now. Join us to celebrate the victory of Filipino intellect over casual Western prejudice. The German engineer, Dr. Richter, rose again, this time without the laughter. His tone was professional, but still skeptical. I will concede the tensile data is interesting, Mr. Alcantara. But how do you address durability, weathering, and insect infestation? These are temporary materials. What about the long-term viability of infrastructure? This was the final, logical line of defense for the conventional thinkers. Miguel was prepared. He explained their proprietary process. A natural, non-toxic treatment derived from local resins and spices that permanently altered the cellular structure of the bamboo, making it waterproof, fire retardant, and completely resistant to termites and rot for a guaranteed period of 50 years, a period comparable to many modern concrete mixes. He then revealed the true genius: environmental impact. The bamboo used in the bridge structure was a hyper-fast-growing species harvested from a sustainable farm, reaching maturity in just 4 years. Every ton of bamboo used removed atmospheric carbon dioxide, unlike steel and concrete, which are massive carbon emitters. The Filipino engineers hadn't just built a bridge, they had built a carbon-negative future. The entire room was silenced, their pride in steel and concrete suddenly tarnished by environmental guilt. The Filipino engineers had solved climate change with a material they had mocked. The conclusion was undeniable. The European engineers had laughed at bamboo as a craft project, but Miguel had proven it was the most scientifically advanced, economically feasible, and environmentally responsible solution available. Dr. Richter walked up to the podium, not to challenge, but to concede. He shook Miguel's hand, his voice humble. Mr. Alcantara, you have shown us that the future of engineering lies not in the most expensive material, but in the most intelligent application of resources. Your system is not temporary, it is revolutionary. The Filipino team's presentation didn't just win a conference. It ignited a global shift in engineering thought. Major architectural firms from Japan, the US, and Germany immediately began collaborating with Miguel's lab, desperate to learn the bamboo secrets. The secret was never the bamboo itself. It was the Filipino Diskarte, the ingenuity born of necessity, coupled with world-class scientific rigor. They had looked at a ubiquitous material, applied intellect where others applied budget, and delivered a solution superior to the world's most vaunted industrial standards. They had turned bamboo from a joke into the gold standard of sustainable engineering.